Let us take one more problem on Regula-Falsi method. Compute real root of this equation by the method of false position. Carry out 3 iterations. So they are asking us to carry out 3 iterations. That means we need to find x1, x2 and x3. Then stop. So what is our f of x from this equation? This LHS is our f of x. Even if they give this minus 1.2 to the RHS, we have to take it back to the LHS and make our RHS equal to 0. So we have taken the given equation as f of x. Now we need to search for the values of x for which our function takes opposite signs. F of 1, we have taken x as 1. The value is negative. So let us go for x is equal to 2 next. Again we got less than 0, that is negative. So we need to again go for x is equal to 3. Yes, we got a positive value for x is equal to 3 and a negative value for x is equal to 2 here. So we got opposite signs. One is negative, other is positive. So we can say our root lies between 2 and 3. Let us say that. Okay, now the root lies near to 3. Why? Because this value at f of 3 is very near to 0 than this value. It is minus 0.6 and this is 0.23, which is very near to 0 than the other one. So we can say our root lies near to 3. Now we take one value which is near to 3 and between 2 comma 3, that is 2.9. So we say since f of 3 is this near to 0, the root lies near 3. So we have taken 2.9, which is very near to 3, and check the sign of this functional value. If you put 2.9 in the place of x in the given function wherever x is there, say we have put here, and simplify, you will get this value. And remember, this is log to the base 10. While pressing in your calculator, you need to press LOG button, not LN. LOG means log to the base 10. So what we got? F of 2.9 is positive. But here f of 3 is also positive. So we cannot say our root lies between 3 and that is 2.9 and 3. We cannot say that because we got same sign. Let us go for one more value, 2.8 now. F of 2.8 will also be positive and its previous value is also positive. So we cannot say the root lies between 2.9 and 2.8. Let us go for one more value, 2.7. The functional value is negative now. We can say now, because this value is positive and this value is negative, we got opposite signs. What we can say, our root lies between 2.7 and 2.8 because the functional values are having opposite signs. So we are saying this is negative, which is listed here, and this is positive, which is listed here. We have to take these things in the ascending order. First we need to write 2.7, then we need to take 2.8. Don't take 2.8 first, then 2.7 then. So our root lies between 2.7 and 2.8 we have written. Now what? Since the interval is small enough, very small, that is the difference is 0.1. Now we can go for x using Regula-Falsi formula. In the first iteration we are going to find x1. In this x1, what is a? A is 2.7. What is b? 2.8. What is f of a? F of a is just f of 2.7. F of b is f of 2.8. Substitute all these in this formula to get the value of x1. So simplify this. Here we have substituted all the values here in this formula. Simplify using scientific calci. X1 is the new root between 2.7 and 2.9. So this is the new root between this. Now let us find as usual, as per the procedure, f of x1, that is f of 2.7404, and check its. Yeah, you got negative sign. We got negative. Now among these two, select the one which gives positive, because we know we want opposite one. Here we got negative, and we want the value which gives the functional value as positive. Where it is? Yes, here, because it is positive. So what we can conclude, our root lies between 2.7404 and 2.8. So we can write the conclusion. We have listed it is negative and it is positive. Now we say root lies between those two. Again we apply the Regula-Falsi method once again, taking this as a and this as b, and find so in the second iteration we are going to find value of x2. A is this, b is this. Where is f of a? Here. Where is f of b? Here. Substitute and simplify. You got x2. As usual we again find what is f of x2, because we know we need to go for third iteration. So f of x2 is negative. Now what we do, we select the functional value, select the value for which the functional value is positive. Yes, here is the positive one. So this is positive. So what we conclude, the root lies between 2.7406 and 2.8. Again we take those two, we say this, and we again apply the formula to find x3, because we want a third iteration. X3, again substitute in the place of a and in the place of b as usual, f of a and f of b. You got this. So this is our final answer, because they are asking carry out 3 iterations. We can conclude our answer as the approximate real root correct to 4 decimal places is this. We have corrected up to 4 decimal places. Since this number is less than 5, we will not give any increment to this. This remains as it is. So we have taken this value as the final answer. This completes the problem.